Good afternoon. It's a pleasure to welcome you to our session today, our annual scientific presentation for 2022 entitled Climate Change, the Effects of Humans and Animal Health. Today we have three very esteemed panelist members who will be presenting on this topic. Our first honorary panel member is Sir Arulkumaran. He is a professor of obstetrics and gynecology at UNIC at our medical school, and he is also Professor Emeritus at St. George's University of London and visiting professor at Imperial College, once again in the UK. He is a former president of the International Federation of Gynaecology and Obstetrics, as well as the Royal College of Obstetricians and Gynecologists, and president-elect of the British Medical Association. Our second honorary panelist member is Professor Stavros. He is a professor of genetics and development at the University of Nicosia Medical School and foundation chair of our newly established veterinary school. He holds a BSc and a PhD in genetics from University College of London and has a long-standing track record and research record through the Medical Research Council at the UK, as well as in Cyprus. Finally, one of our youngest but also most talented members of our department will also be presenting herself and her position today. This is Assistant Professor Souzana Achilleos. She's Assistant Professor in Environmental Health Studies and Epidemiology in our department. She holds a BSc degree in chemistry from the National Kapodistrian University of Athens, Greece, and a Master of Science in Environmental Health from Cyprus International Institute for the Environment and Public Health in association with Harvard School of Public Health. Finally, she has a Doctor of Science degree in Environmental Health from Harvard University in the USA. We have several topics to cover today, and we greatly look forward to the statements and as well as your questions and discussion at the end of the session for today's topics. We will be beginning with Sir Arulkumaran with his topic on overpopulation. Thank you very much.
Thank you very much, Elena, for your kind presentation and introducing me. I'm going to share my slides so that we can start the session. I hope the PowerPoints are audible. And so my topic is actually about climate change is due to overpopulation. So I'm going to demonstrate that the politicians are all talking about various things about carbon dioxide emission, methane emission, industry and oil. But I think it's partly because of our fault. The population is too much for the world to hold. And I think that's the elephant in the room, which is affecting the climate change. Now, overpopulation, before we think about it, we can think about the Sustainable Development Goals set by the global leaders. And they set it with the agenda that everybody should survive, thrive, and prosper, and no one should be left behind. So my talk will cover the SDGs and its relevance to the population numbers, population increase due to increased life expectancy, population increase due to lack of contraception, and overall global picture of the population because of these two, and asking that there should be affirmative action if you want to reach the SDG by 2030 and also reach the climate change agreements, then we have to really think about population explosion and what the professional societies and organizations should be able to do. So the subheading for my talk is World Will Sink Without Contraception, because the Sustainable Development Goal, as I mentioned, survive, thrive, and prosper, and the governments agreed. But the increase in population will increase the deforestation because they want to cultivate more, they want to have animal farms more, and that is going to worsen the climate change. Because of the people needing more and more and more, it will worsen the climate change and environmental disaster, including zoonotic infection like the COVID now, and also lead to flooding, fire, famine, and other public health issues. And can we do something? And one of the things we can do is effective contraception. So this is the United Nations who brought about the SDG goals, 17 Sustainable Development Goals. And each one of these are interlinked to each other. If you are to have no poverty, then you have less people on the world. If you have zero hunger, you have to have less people. If you want to provide good health care, you need less people, and so forth. So these goals are laudable, but cannot be achieved or sustained without it decreasing the population. And the main components which affect the population are births, deaths, and migration. The natural increase is defined as the difference between the live births and the deaths. And the net migration really varies. So really, what is really controlling is the births and the deaths. The rapid increase in population caused by unmet need for contraception is well known. And secondly, we are declining the infant mortality with good health care, and we are increasing the life expectancy with good health care. The population aging will increase. Over 65 years was 9% in 2018 and will be 16% in 2050, and more would be over 85. So it's advances which is causing the issue as well. So this is a projection of the human population as it stands. At the moment, 2 years ago, 7.8 billion at 2020. Some will predict it goes to 15.6 billion by 2100. But if we have effective control, we can contain it by 7.3 billion by 2100. So that's the bottom line we want to have rather than the top line. And the leading, of course, two largest countries, China and India, followed by USA, Indonesia, Pakistan, and so forth. We are talking about millions and billions, and this will need to increase the food supply, water supply, energy consumption, water scarcity. All this will lead to climate exchange, because population explosion will lead to population exploitation of the nature. Now, taking the first point about the increasing age, as you could see, this is the picture in 2021. You can see still the large number of population are in the younger reproductive age group. If you take the whole world of the males and females, if you take a cutoff about 45, the vast majority under 45. This was actually in 2010. So it was a linear figure in developed countries and a bigger figure in the developing countries. But all put together in 2021, this is the picture. So there are more people who are going to reproduce. If they produce 3, 4, 5, then the world will not be sustainable. The second issue is actually about older age group. In 2010, 551 million over 65 years. 2050, it'll be 22 billion over 65 years. And over 80 years, 69 million will become 379 million. So this is going to be an increasing problem. This is due to our wonderful discovery of science. There are public health projects where hand washing, better sewerage, etc., helped in reducing the diarrhea and transmissible diseases. Edward Jenner from St. George's brought in the smallpox vaccination. Semmelweis talk about hand washing and cleaning in Austria. Louis Pasteur and others who made the discovery of vaccines against measles, hepatitis. So people are living more and more. And of course, in addition to vaccination, antibiotics of different types were produced. And that brought us the possibility of people living for a longer life period. So if you take the history, in 1800, the life expectancy is about 30. 1900, it became 45, and 2011, it became 80. And what are the causes? As you could see, early life, things like typhoid, diarrhea, cholera is eliminated because of clean water, sanitation, nutrition. Then it was followed by people dying of infectious diseases, and then antibiotics and vaccination prevented that, in addition to the lifestyle. So we are seeing an increase in the age to which we can live because of health services. And the most vulnerable people in this group is actually the female population. They live more than 7 years compared to the male. This is life expectancy, male versus female, in different countries. And you can see the differences. About 6 to 7 years, they live longer. And if you look at healthy life expectancy without any debility, that too, that healthy lifestyle without debility is fixed. So more women are going to live till older age and have debility as well. And this is not their fault. This is partly because of the composition of the chromosomes, where the telomeres at the end of the chromosome, which gets wasted with the reproduction of cells, get shorter and shorter. And these telomeres are bigger or much greater in size compared to the male. So they have better reproductive possibility. Now, I mentioned about the possibility of reducing it by family planning or contraception. 225 million women in the world each year want to have contraception, but they don't have. The rest of them have, but that is a major problem, the lack of contraception. And if you look at how the population has changed over the years, starting from 1954, you can see the higher the number of absolute numbers, they keep on increasing. So you can see how India is trying to reach China because of the overpopulation. There are 27 million births in India each year. And these countries also has changed in the demographic structure as time goes on. You can see USA is keeping on increasing because of migration as well. But countries like Nigeria are overtaking other countries because of failure of contraception, and Pakistan and Bangladesh. So these are the countries which are contributing more and more as time goes on. And 6 countries other than China put together doesn't equate the population of India. So you can see Indonesia, United States, Brazil, Pakistan, Bangladesh, Japan, all put together is, so 27 million births take place every year in India. So you can imagine building new hospitals, new schools, new water supply, new food for additional 27 million. So that is the arduous task. And that is why SDG 1 and 2 is a difficult task to achieve. The famine is not only because of the population expansion, but also unequal distribution of food, because poor countries have unequal distribution greater, and there is much social economic inequality and climate change. And lack of democracy and civil wars also affect this particular goals of SDG 1 and 2. We take SDG 3, reduction of maternal mortality. Again, we can reduce maternal mortality by 30% if we can give effective contraception. So the goal is to reduce the maternal mortality to less than 70 per 100,000. That will not be achievable unless we give contraception and control the population to a greater degree. And this is a study which we did at Imperial to show 30% of maternal mortality can be reduced by effective family planning or contraception. And nowadays, many women give birth in the hospital, and now a simple few cents worth of postpartum intrauterine device can be inserted. So this mother is feeding a baby, another baby in the cot, and she'll have harder task of looking after the family. So population explosion is a rapid increase in population due to decline in infant mortality, increase in life expectancy, and lack of contraception. So we had to look into the issue of this about lack of contraception in a big way if you want to adjust this. And this is a scene if you go to a town or a city in India, crowded, and they have 4 people or 5 people in a motorbike going. And I'm sure you'll hear about pollution and health issues in the next talk. And the only way we can manage trying the people exploiting the environment here, they are not in our houses, they are going into the jungles, building, making agricultural lands, farming lands, and so on. So if you look at the distribution of terrestrial mammal biomass 10,000 years ago, humans were a small proportion, but now we are expanding in 1900, and then as we go along, the cattle farming has become a big industry, especially in South America and North America, and also Australia and New Zealand. And the other livestock also is increasing, and the population is squeezing the wild mammals. So they have no other place to go, but they get on with the human host. So that is why the zoonotic infection happens, and you are very well aware of the COVID, and you will hear more about it in one of the following talks. So it is not only we are destroying the environment, but also the problem of zoonotic infection is a reality. And environmental change like flooding is no wonder because of the trapping of the heat and the changes which it brought by melting the ice. And as you can see the world map, the vast majority of area is ocean, which is blue in color. So if the ice tips in Antarctica and Arctica can melt, then it can easily drown everybody. And you can see the satellite data from 1999 3 to present, and you can see the sea height variation going up and up and up, going 2 millimeters per year. And small islands can sink if you don't provide contraception. You heard the earthquake near Tonga, it nearly wiped it out, but fortunately they survived. But if flooding increases, most of the cities like Sydney or New York or Paris are going to be underwater, if we are not careful with the environmental change. And the only way I propose is actually we, rather than doing the medium of projection in 2100, we had to advocate possibly 2-child families to stabilize. And if you want to really reduce it, then we have to bring it to 1-child families. So by 2200, it'll be okay. So although we are going to switch to clean energy, clean way, vegetarian food, etc., but I think the main culprit here is the overpopulation. And that can be tackled very simply by a few dollars. Here you can see a $70,000 missile flying at a cost of $3,600 per hour to kill people who are living at less than $1 per day. This money can be easily set aside to achieve the SDGs of good nutrition, contraception, and improvement of environment globally. So I would rest my case by saying cause for climate change is overpopulation. Elephant in the room is overpopulation, but politicians, scientists, and religious leaders do not talk about this for political correctness. Thank you very much for your kind listening.
Thank you very much for that very comprehensive presentation. There are very many interesting and innovative aspects being raised, which I'm sure we'll have the chance to discuss analytically at the end of the session. So proceeding on, we'll be proceeding to the second speaker for today, Dr. Souzana Achilleos. You may please proceed to the floor. And the topic of Dr. Achilleos is the effects on human health. Thank you.
Sorry.
We can see your slides.
Can you hear me?
Yes, we can.
Oh, okay. Sorry. Sorry about that. Thank you, dear Elena, for the introduction. Good afternoon, everyone. Welcome, and thank you for being here with us today. So before we start looking into the human health effects of climate change, first I would like to take a couple of minutes and describe this phenomenon. So when we talk about climate change, we refer to the long-term changes in temperature and other weather patterns. And of course, variation in weather patterns is natural, and climate can vary mostly because of the variations in the solar cycle. So the climate we have on Earth depends on the absorption and loss of solar energy. And this interchange of radiation depends on greenhouse gases, which some of them occur naturally and are essential for life on Earth. But since the 18th century, which was the time of the Industrial Revolution, we had an increase in human activities, and that came with burning of fossil fuels like coal, oil, and gas, deforestation, urbanization, and so on. And because of this, we have observed high levels of greenhouse gases. And as we can see here in this graph, for some of the major greenhouse gases, such as the carbon dioxide, methane, and nitrous oxide, we have observed a significant increase, especially after the Industrial Revolution. Now, when greenhouse gases in the atmosphere increase, the amount of the radiation that is trapped in Earth increases as well. And in that situation, the greenhouse gas emissions act like a blanket, we can say, which is wrapped around the Earth, trapping the sun's heat and raising temperatures. Now, as a result of this increase in the greenhouse emissions, there has been an irregular but significant increase in global temperature, as we can see in this graph. And at this point, the Earth is about 1.1 degrees Celsius warmer than it was in the pre-industrial times in the 1800s. Just to remind everyone, the Paris Agreement's long-term goal is to keep the rise in the average global temperature below the 2 degrees Celsius, but preferably to below 1.5 degrees Celsius. Unfortunately, it seems that we may not be able to track this agreement, but let's hope for the best. In addition, many people think climate change mainly means warmer temperatures, but temperature rise is only the beginning of the story. The Earth is a system where everything is connected. So by changing one factor, we can actually influence change. We can influence changes in other factors. So what we have been seeing are reductions in the Arctic sea ice, in the Greenland ice sheet, as we can see here on the figure, snow cover and permafrost. Also, small temperature changes can lead to sea level rising, what we call thermal expansion, but also melting of ice can also bring large volumes of water in the sea and contribute to the sea level rising. Lastly, increase in temperature intensifies the global water cycle, which means it makes it more variable and it changes the severity of wet and dry events. So some places will experience heavy precipitation, or other locations they experience droughts. Because of all these components, climate change is likely to affect the human society and human health, but also the natural environment in many ways. So it will affect forests, coastal areas, other natural areas, water resources, and agriculture. So in regards of human health effects, climate change can affect the humans directly through extreme weather events and through different environmental exposures. So here I have 5 categories related to the health effects from climate change, and that includes extreme weather events, respiratory diseases, food safety and nutrition, infectious diseases, and mental health. As we're going to see in the next few slides, these categories, though, are overlapping and interactive. So we cannot examine or study one by one, in isolated manner. So let's start with the extreme events. One example of that includes the heat waves that most of us mostly experience at least a few in our lifetime. And that refers to periods of unusually hot weather. Now, scientists have observed that the frequency, the intensity, but also the duration increases over the recent years. And heat waves have been associated with higher mortality, but also with cardiovascular and respiratory morbidity. And of course, with reduced labor capacity, especially in regards of workers that they work outside. The 2003 European heat wave and the 2010 Russian heat wave are actually some of the major examples of life-threatening heat waves. The European heat wave, it was actually one of the hottest summers since the 1540, so nearly 500 years ago. It reached maximum temperature of 40 Celsius, and the heat wave was responsible for more than 60,000 deaths. People died because of stagnant air, heat stroke, and dehydration. This is an example or some data that some authors put together for Paris heat wave. And here we can see the deaths for the previous 4 years earlier than the heat wave in 2003. And what they have observed was the number of excess deaths followed the same pattern as the increase in temperature. And they have estimate of more than 1,000 extra deaths during that heat wave. And from what happened in France, and of course in Europe in general, the French government developed a heat health watch warning system and set a preventive action plan in 2004. So there were some at least good outcomes of that. In regards to the Russian heat wave, just mentioned briefly that it was happening in the summer 2010. We had a series of heat waves. It was one of the most devastating events in Russia that caused more than 55,000 people to die. And people died because of overheating, forest fires, and the smoke, but also there were victims, the people who drowned during the summer as because of heat stroke, and also drunk swimmers that they had to jump in to cool down. Moving on to wildfires. We know that large areas have been getting hotter and drier, and the number of wildfires has actually increased substantially since the 50s. Here we see the trends in the annual number of large fires in the Western United States. So in most places, the wildfire numbers have increased since the 80s. And here on the left, we see a satellite image of the California fires in the last summer, actually. It lasted a few days. It was very intense, where it affected actually on the East Coast as well. When these events take place, besides the environmental, of course, impacts, we have in terms of health impacts, maybe some mild symptoms such as irritations, but they can also exacerbate cardiac and respiratory problems, especially among firefighters and other vulnerable populations such as children and the elderly. Now, other parts of the world experience more heavy rain events, and we have evidence that the intensity, duration, and frequency of floods, hurricanes, and other tropical storms increase over the years as well. Now, because of the high heavy rain, we have different impacts. We have high risk of infectious diseases, especially waterborne diseases. For example, flooding in the Dominican Republic led to the malaria outbreaks in 2004. Floods and heavy precipitation also associated with high number of injuries and deaths. It affects the drinking water and agriculture, and also cause people displacement, so affects people to migrate to different areas because of what they are losing. Now, moving on to respiratory health. We have seen that extreme weather events can contribute to respiratory health, and especially because of the changes in the different meteorological parameters. We see increase in the respiratory morbidity and mortality, especially in adults, patients with chronic lung diseases, but also the effect of heat waves in children. In general, the extreme heat and high humidity trigger also asthma symptoms. Now, besides this effect, the climate change can deteriorate air quality. So increased temperatures due to climate change can lead to increased ground level ozone and other photochemical products, which in turn cause airway inflammation and damage lung tissue as well. In addition, by increasing carbon dioxide in the atmosphere, we promote the growth of plants and also the release of airborne allergens such as pollen. And in turn, we increasing the allergic sensitizations and asthma episodes. Now, in terms of food, climate change can act both as a driver, but also results from food production. And we know the food industry contributes to greenhouse gas emissions that cause later on rising temperature. But higher temperature in turn affects the resources to produce food. On average, we have seen that global food production decreased by 2% per decade. This is because of increased temperatures and water shortage or even heavy precipitation that can harm crops and reduce yields production. Also, changes in the snow cover and the permafrost in many Arctic regions have also disrupted food supplies, especially when some regions, they do count on hunting and fishing and some other activities. In addition, many weeds, pests, and fungi also thrive under warmer temperatures and wetter climates, and with higher CO2 levels. So we're expecting that plant diseases also increase over time with climate change. Higher concentrations of carbon dioxide, they may stimulate the growth of some plants, but they lower the levels of protein and essential minerals in a number of crops. And lastly, we also interfere or reduce fish availability, along with overfishing, as we saw before with overpopulation, by increasing the levels of carbon dioxide in the atmosphere, we're making the oceans more acid, and that affects the formation of shells for different organisms and therefore the other dependent species. Now, in terms of food production, different places will be affected differently. So here we have how climate change has affected global food production in different areas in terms of rice, maize, and wheat. And here the authors have found that the climate change has impacted most negatively in Europe, South Africa, and Australia. Now, in terms of infectious diseases, climatic conditions are becoming more suitable for the transmission of multiple infectious diseases. And by also the fact that we are affecting maybe the biological features by favoring the transmission and so on. So in terms of freshwater and marine ecosystems, the floods can contaminate the drinking water and also the recreational waters, meaning the rivers and coastal beaches, because maybe from sewage overflow or from water runoffs from maybe urban or farm areas. And an outcome of that is different outbreaks of diseases, including some gastrointestinal diseases and illnesses. In terms of marine ecosystems, by increasing the sea temperature and increasing the nutrient loading, we enhance harmful algal blooms, what we know as red tides, but also cyanobacteria, for example, the Vibrio cholerae, which favors in warm waters. In terms of foodborne diseases, frequent warm days and greater humidity increases the risk of food poisoning from different pathogens such as Salmonella or Campylobacter. In terms of vector-borne diseases such as malaria, dengue, West Nile virus, here the seasonality, the distribution, and the prevalence of these diseases are influenced significantly by climate factors, especially by high and low temperatures, extremes, and precipitations. For example, an increase of 0.5 degrees Celsius, we have an increase in the prevalence of mosquitoes by 30 to 100%. So what we are expecting with climate change is to have both short and long-term effects on vector-borne diseases in terms of the transmission and infection patterns, seasonality, but also the geographic area that's been affected. So for example, here we have the distribution of dengue and how it changes over the year and how much spread is becoming. However, there are many factors, for example, how the pathogens will adapt and change, the changing ecosystems and the land use, demographics, and other factors that interactive and make it difficult to predict the effect of climate change on vector-borne diseases. Last but not least, climate change can also affect mental health, especially in terms of post-traumatic stress disorder, depression, and anxiety. How? Well, different ways. First, weather is a risk factor for people with underlying mental illness, such as dementia, depression, suicide, maybe. Also, we have direct effects through personal experience of extreme weather events, such as floods, hurricanes, and people may lose their properties or they may lose family, friends. They may have to relocate after a disaster, or maybe because they don't have the needed resources that they should. Disruption in social, economic, and environmental health determinants exacerbate a variety of mental health conditions from climate change. And also, some people may experience maybe emotional distress or anxiety when they realize and understand the consequences and the threats of global warming. Now, in terms of which population groups are more vulnerable. So every society, of course, is vulnerable to the impacts, but the nature and it will vary across regions and communities and sometimes over time. So to understand that a little bit better, in terms of vulnerability, meaning the tendency to be adversely affected by climate-related health effects, is a function of its exposure to climate-related risk. So factors like poverty or occupation will affect the exposure to climate change health threats. Also can be affected by sensitivity or susceptibility to harm from those risks. So for example, underlying health conditions may make people more likely to have a serious health outcome from climate change health risk. And also depends on the capacity for responding or coping with climate variability and change. So all these three elements depend on social determinants of health. And in disadvantaged groups, the social determinants of health contribute to increased exposure, increased sensitivity, and reduced adaptive capacity. So in briefly, poorer communities tend to be more vulnerable to loss of health and life, while wealthier communities usually have more assets at risk. Disadvantaged people that live in poorly maintained infrastructure or areas of increased burden of air pollution, or maybe limited access to healthcare services, or even no access to air conditioning and other factors, they can be affected more as well. Regions affected by violence or governance failure are more vulnerable. Migrating populations, areas with the greatest population growth. Development challenges such as gender inequality, low levels of education, and differences such as in age, race, and ethnicity among communities and other socioeconomic status can also affect. Unfortunately, the negative health consequences harm more the poor and disadvantaged people who are contributing in general in the least towards the greenhouse gas emissions. Other people that are more vulnerable are people with chronic medical conditions, people with disabilities. Also, the different life stage can also affect. So mothers and babies can also affect it more, infants and toddlers, school age and older children through their activities, but also elderly population. Wrapping up, I have this infographic from the World Health Organization that has an overview of the climate-related health risks, their exposure pathways, and their vulnerability factors. So what it's showing is that, of course, as we said, climate change impacts health directly and indirectly, but is strongly mediated by environmental, but also social and public health determinants. So it's still a challenge to accurately estimate the scale and the impact of many climate health risks. We're expecting that the short and medium term, in the short and medium term, the health impacts of climate change will be determined mainly by the vulnerability of populations, where in the long term, the effects will increasingly depend on what actions we take to reduce greenhouse emissions. And because of that, I think both mitigation and adaptation strategies are equally important to address this issue, especially since we keep increasing the carbon dioxide emissions in the air. It's a challenge, of course, to reduce greenhouse gas emissions from fossil fuel combustion, and especially wanting to maintain a productive economy. But climate science tells us that if we want to have a chance of future in a livable world, we need to reduce fossil fuel emissions. And several authors actually have started to investigate what are the potential health benefits of transiting to a low carbon economy. So, for instance, dramatic reductions in the use of animal-based foods and energy intensive transportation, such as cars, airplanes, can lead to reductions in obesity, diabetes, and heart disease. Improvements in urban transportation systems can reduce greenhouse gases, but also increase physical fitness. And by reducing, of course, burning of fossil fuels, we can decrease cardiac and respiratory disease and death attributable to air pollution. Towards this end, I would like to take a chance of today's talks and just remind everyone that we can all contribute and reduce our carbon footprint through our daily life and activities, from simple like recycling, maybe get local food, reduce food waste, use more energy, green energy, and everything can, everyday life activities can matter. Thank you.
Dr. Achilleos, thank you very much for that wonderful presentation. It was excellent. Last but not least, we have the pleasure and honor of having Professor Marles presenting us today. As stated earlier, Professor Marles is the foundation chair of the UNIC Veterinary School, as well as Professor of Mammalian Development, Neuroscience, and Genetics at our medical school. So Professor Marles will be speaking on the topic of effects on animal health. Professor, the floor is yours. Thank you.
Thank you very much, Elena. Can you hear me? Yes? Good, thank you very much.
Yes, we can.
So, okay, let me arrange that. So, what I'd like to do is really expand on the previous talks, and in particular, highlight some of the points that Arul made in his talk. Now, we're talking about the effect of climate change in animal health, but of course animals, which are presented here, are major contributors to the climatic change, the so-called greenhouse effect, because they release a tremendous amount of greenhouse producing or causing gases, and that is methane. The climatic change itself is promoting the growth of parasites and unicellular organisms, prokaryotes in particular, which are then infesting the gut of the animals, and thus producing a different, what we call gut microbiome, or a composition of it that is actually contributing more and more to methane emissions. So this cyclical, if you like, triangular relationship between the health of animals and climatic change, it's something that is at the very center of research. And I'm going to highlight in particular some of the research we started doing here at the University of Nicosia, looking at gut microbiome in Cyprus. So what is the contribution of various types of animals in actually methane emissions? So cows produce a lot more than any other animals, including ourselves, of course. So cows produce anything up to 120 kilograms of methane per year. So they are contributing significantly. And if we do take into consideration that all these are farm animals, so the increase of population itself in terms of methane emission, it doesn't contribute significantly, but the increase of farm animals in particular actually does cause a lot of greenhouse effect. So we need to look at here how we can actually reduce, if we can, methane emission, which has probably 50 times more of greenhouse effect than CO2. So this is really the contribution of various greenhouse gases into plant warming. So carbon dioxide is contributing 76%. So this is clearly part of the industrial activity of humans. Methane actually contributes significantly, and the actual contribution of the global warming potential of each gas here is methane. So methane is significantly more potent in promoting greenhouse effect than actually carbon monoxide is. So, and this is really the contribution by various factors in the greenhouse gas emissions. So here again, agriculture is contributing approximately 15% in greenhouse gas emissions. So that's really what we're looking at here to see if we can reduce it. So now the climate change, of course, has an effect on the health of livestock and their well-being, but also in the production and reproduction, in particular production. And therefore, we need to look at possible ways of adaptation and mitigation strategies that will actually reduce the negative impact on the health of animals as a result of climate change. And as I said, some of it is actually caused by the animals themselves, as I highlighted earlier. So, and that ill health of animals impact on the health of humans. And I'm going to use as an example milk to demonstrate here in Cyprus in particular how we actually have a significant challenge in actually producing much better quality of milk, because the quality of milk that we produce as a result of possibly climate change as well as farming practices, it's not good. So at the global level now, going back to globally, animal production, of course, must increase because we need more food. And that in itself means that we need to have more improved livestock systems like grazing, mixed farming systems, industrialized systems, and so on, so that actually can accommodate the change in the requirement for more food, but also at the same time mitigate climate change as a result of the increase in the livestock population. So in the last quarter of the century, where humans have concentrated on improving productivity, on changing the environment, on improving, of course, the nutrition management, rather than adapting the animals to be more resistant to stress, which is actually caused by the climate change. So, and that has led to an increase in productivity of domestic animals, an increase in the numbers of them as well, but also increase in their sensitivity rather than what we call the thermoplasticity, their ability to actually counteract climate change to the whole environment. So if we look at how climate change affects animal health, so heat stress clearly it's something of major importance. Of course, here in Cyprus, we have particular interest in that. So that's changing the behavior of animals, their health and well-being, their productivity, and this can be tackled in some ways, but not totally, by adapting these animals through genetics, nutrition, and management to the change in their living conditions. So here in Cyprus, for instance, just to give you an example, we're using cattle as a major as a really major animal for producing milk. Now, cattle that we use in Cyprus are not adapted to actually to living in the temperatures and humidity levels that are prevalent in Cyprus. So clearly, we're using animals that are not adapted, and their productivity is going down as well, affecting their health too. Now, let's look at the case of milk, because milk is really a well-known staple for human consumption, and here is Cyprus. So here in Cyprus, we consume a lot of milk. We're #1 in Europe, of course. We're producing a lot because we like to convert it also to cheese, halloumi, as you know. And if we are looking at the map also, this is Cyprus and Greece, we're producing a lot of milk. Milk from other sources too, we're producing a lot of it. So, and the raw cow's milk delivered to dairies, so it increases every year dramatically. So we have an increase in milk, but we need to see if the quality of the milk is what it should be, and also if climate change is affecting the quality of milk. So, dairy farming industry, it's in Europe, it's just under 12% contribution to the economy. Approximately 45 million metric tons of dairy products are consumed in Europe. In Cyprus, we consume a lot and we produce a lot, 274,000 tons, and that's going up about 10 to 12% every year. And we have just under 400 farms, 358 in particular, which are not evenly geographically distributed, and that's a major issue. So now, if we look at just cattle, then we need to really look at the microbiological load of these animals and how that's affecting, in particular, the health of animals, and that's mastitis, and of course zoonosis. That's the microorganisms that are transmitted to humans, and of course also the use of antibiotics in that setting. So let's look at mastitis, which is really something that interests us a lot here in the University of Nicosia. So it is an expensive disease, of course, because animals need to be treated, and about a third of all dairy cows in the world will actually get it. So the bacteria are actually getting into the animal through the pore here, and of course that's getting into the milk. That's where the milk is being produced, and the animal is responding to this to fight this infection by delivering white blood cells in the milk to fight infection. So and if it's unable to find it, then you're getting what you call clinical mastitis. In other words, you can see that this animal is unwell, but a lot of animals do not develop clinical symptoms, but nevertheless they have an infection, and they have what we call subclinical mastitis, which is asymptomatic, but it is a major problem here in Cyprus. And I want to actually highlight that because it's of particular interest to us locally, as well as from a research perspective. So milk that is actually been removed from an animal that has mastitis looks like this. It's clotted because of the enzymes that the bacteria are producing, and they're clotting the milk. And there are various types of bacteria that can actually do that. And of course, these animals are treated with antibiotics and so on. However, subclinical mastitis is a lot more frequent, and this is the infection which is without symptoms and is difficult to detect, and it's about 40 times more prevalent than clinical mastitis. Now, milk that is consumed from animals with subclinical mastitis is actually in our everyday life, but we actually consume a lot of the bacteria that actually are populating these subclinically infected milk, and that's really an issue. So all dairy farms have cows with subclinical mastitis. In Cyprus, we have a lot of it, as I said, with Stavros and so on. So and the infection persists in the entire lactation, and that's a major public health risk. And I'm going to highlight how we can actually deal with this. So one way of measuring what's in the milk in terms of bacteria, instead of counting the bacteria, you count the white blood cells, and white blood cells we call the somatic cell count. And the cutoff is here. If you have 400,000 somatic cell count per ml, if you go over this, this is obviously mastitis. The actual upper limit is 400,000, and all Cypriot milk is there, and it's probably the most bacterial infested milk in Europe. So pasteurization removes part of it, removes part of the problem, but not all the problems. So that's clearly something that we really need to look at. Because the way you actually pasteurize milk doesn't actually kill all the bacteria. So in addition, you got zoonotic diseases. In other words, you're getting various types of monocellular organisms like Brucella, tuberculosis, and Solistia. All these are caused by bacteria that are actually living within cattle in particular, and that's also a public health risk. So if you're keeping animals, and I'm going to come to that in a minute, if you're keeping animals and the conditions that are not really optimal for housing the animals, that's what we do here in Cyprus, then you're promoting the infestation of these animals with these diseases. You're promoting, you're increasing rather the bacterial load in the milk. That's a public health risk. So it really is kind of a cyclical thing. So we need to really tackle that. And on top of that, of course, we have the use of antibiotics. And as you know, here in Cyprus and in Greece and various other places, we're using a lot of them. We're just creating, as what we know, antibiotic-resistant strains. And the more you use, the more you're developing those strains. So the worse, if the conditions of keeping the animals are worsening, and then clearly you're overusing this and you're exacerbating the problem. So that's and about 62% of mastitis is caused by agents that are resistant to antibiotics. So as you all know, the heavy use of antibiotics because of the very large, very widespread use of them goes into the food chain. So that goes into various products in addition to milk, meat, eggs, and so on. And that's harmful to the use of humans. So really how this links to climate change, right? If you have climate change that is actually promoting the growth of bacteria, and if you're not really having the optimal conditions of keeping these animals, then you have more bacteria, more use of antibiotics, more resistant bacteria getting into the food chain. So that's a kind of a chain event. Now, I'm going to finish off by the milk quality and also in particular concentrate on Cyprus. So we say climate change, of course, is important because it is affecting the health of the animals, and of course that's affecting the quality of the products we get from animals and milk in particular. So now, cows usually are housed all year round with no outdoor grazing, and that's a really major issue because that's putting them in a situation where there is a lot of heat stress, and therefore there's a significant host-to-risk infection and a susceptibility to bacterial infection. So these animals have contained in these closed farming environment, as we call it, which is now really creating a situation as a result of climate change of exacerbated conditions, particularly heat and humidity, that's increasing the infestation of bacteria as well as the variation of them. So, and therefore, these are really these farms are massive incubators of different types of bacteria and in different quantities, but in some ways are actually augmenting also methane release and therefore worsening the climate change. So another problem that we have, which is really a bad practice, where these animals, these farms are close to each other, and that's creating a problem with disease transmission. So highly infested units close to each other, getting the problem worse because the health of the animals living in bad conditions in a situation where climate change is actually changing all the time, then the situation goes on and on. So, and the research in the Mediterranean region is very limited, so we're very interested in that. So now what we want to do here in the University of Nicosia, and we started this with my colleagues Mavridis and Stavros, who I believe are attending this conference, is to really look at the composition of the gut microbiome of cattle here in Cyprus and see if the newborn babies are actually receiving some of the parasites and some of the prokaryotes that the mother has, and we're looking at in the first week of age. So we want to see if there is this vertical transmission, because if that is the case, then clearly we can take measures to reduce that. So, so the gut microbiome is really of enormous importance for the health of the animal, and of course for the health of the offspring in terms of infection, milk production efficiency, because what you have in your gut is affecting meat and milk production, and also the quality of the milk. And the quality of the milk not only is affecting the actual marketability of the milk, but also the health of humans that consume the milk. So environmental factors need to be studied, particularly humidity and temperature, to see if that's changing in different environments. So we're looking at that these days. So what are the benefits for farming if you actually do these kind of things? But clearly, if you look at what the composition of gut microbiome is, then and you can actually see how this is transmitted, and also farming practices in particular, then you're improving clearly the health of animals. So improving gut health, minimize parasite infection, because you can actually fight parasites that are actually causing ill health to animals. You can minimize the use of antibiotics, which is very important because more antibiotics are creating antibiotic resistant strains. You can improve animal welfare. Now, if you go into most farms here in this country, I think that we will have a serious issue with animal welfare, because the farming conditions in closed farming are not conducive to what we call modern animal welfare practices. So, and of course, we need to clearly develop more knowledge about breeding programs. Now, the benefits for farming, if you do that, of course, there are economic benefits. That's increasing milk and meat production, because animals that are living in bad conditions, infested with bacteria that are causing them ill health, clear, and animals that have lower quantity of milk produced, lower meat production, and of course, that's of economic benefit. So if we change that practice, then clearly we improve milk and meat quality, and lowering eventually the greenhouse emissions. So the way forward, in particular in this country, is really to use to develop more productive and adapted to climate change animals, and that's really not the challenge for this country, but also for many, many countries that are in the epicenter of climate change. Cyprus is one of them, through genetic improvement. Now, we have the tools these days to actually select what we call the phenotypes, those characteristics in the animals that are making them more adaptable to climate change, because we can also at the same time look at the genes that confer this ability of animals to adapt. This, and that's very important, will reduce the number of animals, because we want healthier animals, more well-adapted animals, and more productive animals, so we can actually accommodate the increase in the needs for the goods we receive from the animals by making the animals more adapted to the environment and more productive. And we need to have better farming conditions, and in particular, open farming. That's very important for Cyprus. It's very important for many other countries, because the bacterial load that actually exists in closed farming is enormous, as I highlighted earlier on. And finally, it has also an impact. This kind of practice has an impact on methane emissions, because if you have animals, if you have less animals, which are more productive, then clearly you have a reduction in methane emission. And remember, methane is actually 50 times more potent in causing the greenhouse effect than CO2. thank you very much for that.
Thank you very much for that very interesting and excellent presentation. So now that we have concluded all the presentations by the presence of our panelists, and thank you very much for that, I would like to first open up the floor for questions from our audience. For those of you who wish, you may raise your hands and or open your microphones and pose your question, or you can pose them in the Q&A box that you can see on the lower right hand of your screen. So are there any questions from the audience? Mrs. Arietu, if you would like
Thank you so much. Can you hear me?
Yes, we can.
Okay, great. First of all, I'd like to thank every presenter for their presentation. They were very interesting and I'm glad I attended. My question is on the second presentation, actually, and it has to do with climate change and mental health. So is as follows. Has the climate change increased or deteriorated cases of patients suffering with depression specifically? As we often hear that sunny weather is associated with happiness and motivation, whereas sadness and lack of motivation is respectfully connected with a darker weather. So I can only imagine the impact it may have when it is a constant or, let's say, more than the norm phenomenon.
Yes. In general, it has been shown that hot weather has been deteriorating depression symptoms. Doesn't have to do with the sunlight, but it's more about being uncomfortable in high temperatures. So yes, sunlight, of course, makes you feel better, and it's very positive and nice to have. However, in extreme, like similar with extreme cold weather, extreme hot as well, you make people, feeling more anxious. So that's where the part of climate change affect negatively on the mental health in terms of depression. Of course, you may have other events that associated with climate change that can affect people's, maybe something happened, something like a climate-related event, maybe like a hurricane that damaged their house. So if someone with depression has that and, experience such an event, or even a wildfire, so even that indirectly affects their mental health.
Wow, that's very interesting, actually. I could never relate discomfort with mental health, but since it's happening, it's truly interesting. Thank you.
Yeah. And just to add, there have been many studies that have been associated with mental discomfort, especially indoor. So on top of that, if someone who lives indoors but doesn't have maybe access to air conditioning systems, or in general their indoor thermal comfort is not appropriate, then of course will affect their mental health as well.
I'm not sure if Arul or Professor Malas would like to add anything to that.
Elena, I got a question on the chat box. May I take that one?
Yes, of course, please.
Overpopulation exacerbates climate change. What is the most fundamental aspect that can curtail climate change or mitigate its devastating effect? So I think the short answer is all the three talks gave pointers really about, first one was about overpopulation. Second one was about the general incidence of health issues for humans. And the third is of the animals. So all three will contribute to problems with climate change. But in addition to, if I take the overpopulation part, which I expressed, is not only the number of people in the planet. You can imagine if it goes from 7.5 billion to 10 billion, then we are increasing by another 25% of population. We need more food, more destruction of forests, and more plantation, more animal husbandry, and so on. But also the part is unequal distribution of food. A lot of food is wasted in the Western countries compared to the paucity of food in the poor countries. So if they can distribute in some way, that is another thing. And the third I would add is actually, although we talk about industrial green gas emissions, we mustn't forget about what the amount of energy which is used in production of arms and so on in different countries. I showed at the last slide about flying a drone causes so much of power and energy, and that causes money, that causes problems as well. So if we can stop the wars and live peacefully and give everybody some contraception, I think, might be we had to add some contraception to water in some places. It's a very sarcastic way of putting it, but that is also part of the problem. So overpopulation, misuse of energy to produce things which are really not wanted, like in the war, maldistribution of food, all this will add. So there's no one solution, but there are a number of solutions. Thank you.
Thank you very much for that very comprehensive description and response. Thank you. We have one more question from the audience. Mrs. Fotiu, would you like to open your microphone?
Yes, hello. First of
Hello.
all, thanks to all the presenters for the wonderful presentations. My question relates to COVID-19 pandemic. Whether COVID-19 pandemic has affected in any way climate change in terms of human health or in terms of population. So both of the presenters, the first two, can answer the question. Thank you.
So maybe I'll start and then Souzana can. Well, there's no question that the COVID pandemic has devastated the population of the world in a big way. A large number of people have died because of this infection. We don't know when it is going to end, but it looks like it might end, maybe end of 2022 or 2023. It might become an endemic disease and people with immunization and natural infection might get immunity. But certainly it has affected. But the worry here is not only the COVID pandemic. These pandemics like the Spanish flu was 100 years ago. Before that, 100 years ago was cholera, whatever it is. Every 100 years there has been a pandemic. So the more we invade into the natural territory of the animals in the wild and so on, the more likely we are going to get zoonotic infections. And as mentioned in Professor Stavros' talk about the way the animal husbandry is kept in a close situation. When the animals are close together, I'm sure they are likely to pass the infection from one to the other. And also the use of antibiotics, he was mentioning about the unjustifiable use, I might say, and sometimes they give it in large stocks. That increases bacterial resistance. So we are going to see more and more of pandemics, maybe not every 10 years, maybe every 50 years, but it is going to come unless we let the animals in the wild live their own life and we live our own life, and also try to reduce the consumption of meat and meat products and so on. So it is a complex equation, but certainly everything adds to one another, I think. All the three topics adds to one another. Thank you.
Thank you very much, Arul. Souzana, would you like to add anything to that, as it was also addressed to you?
Yes, as well said, it's very complex, and some of these, the zoonotic diseases, some of these viruses, they may become more resistant to heat and other climate related parameters. So it maybe, we don't know for sure, later, in the future, maybe they will last longer, especially these types of infections. What it was surprisingly to see is that whether actually during the pandemic, the CO2 emissions, where they have decreased. But even during the pandemic, we see that even we were keep, polluting even, the same rate. So for me, that was one of the most surprising things, in addition to what we know so far and what was said. Thank you.
Thank you. That's very interesting. And I'm sorry.
Elena, can I just add something?
Yes, of course.
Which is not really directly to COVID-19, but of course there is a question about how SARS-CoV-2 actually developed and got transmitted into humans. And of course, we all know that these unicellular organisms, like bacteria, viruses, not organisms, but there are obviously biological units. If you have bad farming conditions convert animals into massive incubators of producing faster, potentially new strains of either bacteria or viruses that can get transmitted faster to humans. So, and I can bring one example just to highlight that, which doesn't relate to animals, but in Georgia, a method was developed many years ago to actually fight bacteria by looking into the sewage of the city to develop phages to fight all types of bacteria, even antibiotic-resistant bacteria. Why did they look into the sewage? Because it was an area of heavy fermentation. That's what you need to think of animals. If you're having animals in bad farming conditions, it's like having a massive, fast incubator of producing potentially threatening microorganisms as well as viruses. So in an indirect way, I want to highlight the importance of changing farming practices because this will precipitate the transmission of zoonotic diseases.
Thank you. That's extremely interesting. And if I may, since I don't see right now any additional questions in the chat box or in the Q&A, if I could expand.
Elena, there is one in my Q&A. I don't know if it's shared, but if I can share I have a question. Okay. I see from Malaki a question asking whether there are any positive effects of climate change. So I think we can all, if we want to contribute to that, but that's an interesting question. Well, there are maybe a couple or a few. What I can think right now is that since we're expecting winters maybe to become less, we are going to have like more mild winters. So maybe in the long term, we're expecting maybe less deaths from extreme cold in some places. Also, as I said before, the production of crops may be affected, some places negatively, other places positively. So, maybe warmer seasons will be longer in some places, so that will help with the crops production, so for farming. Other people believe that by, the melting of ice can actually help the shipping industry, and we will help maybe the exchange of products, and especially in places where they're a little bit more isolated in the more cold places. So there are, but there is also, some feedback loops from the positive, and we should weight both negatives and positives. And I think we all agree that the negatives are more than the positives.
There's a question about, Elena, there's a question about vector-borne disease, actually. I think Souzana mentioned about the vector-borne disease increasing with floods and so on, because the mosquitoes can multiply with certain seasons, and if it is flooding and so on. So in some of the countries where the sanitation is poor, like the rural parts of Brazil, for example, the Zika virus took an upper hold. So you get less of a problem in the cities, but more of a problem in the periphery because of the vectors. So that tend to multiply with stagnation of water and so on and so forth. So that also is a problem, because the more we go into the periphery and build smaller houses, not proper drainage facilities, no proper sanitation, not only the infecting organisms themselves, but the vectors also increase, and that can cause disease as well.
Thank you very much for that. Since I don't see any other hands raised for questions, I would like to pose some questions if I may.
Sure.
Wonderful. So first of all, I'd just like to backtrack a little on the position statements made earlier to the questions. So the first one being in regards to the COVID pandemic, and I do like to believe, I am a positive person by nature, so I do like to believe that there's always a silver lining in every challenge. I know you mentioned about the effects, that there was a diminishment in CO2 emissions. I'm wondering if we have some information, especially from the countries that have these extended lockdown periods, such as Australia, such as Greece, and other countries, if we have some kind of indication of how much would we have to really shut down to have some kind of practical imprint on the environment. Because there's some countries that it was really a live experiment, if you like, if it would be practical to really cut down and follow up on all the issues and goals that were also posed in the beginning by Arul on the SDG goals. So do we have any information from that? And I'm opening this up to the floor to all three of you, of course, for any insights. Or does it seem that even with the lockdown, it just doesn't, it's not enough?
No, I think it's an important question, Elena, that the pollution index was studied in different countries, especially in capital cities where you can't see even the next person walking, you know, as with a haze, dust, and so on. So that pollution level came down in big cities in China and India, like New Delhi and so on and so forth. Whether they systematically, I'm sure they will have systematic recording over the days and so on, when they had weekdays and where they had lockdown and the days they didn't have lockdown and so on and so forth. So that data should be available. I read the data here and there, but I can't give you a composite answer because I didn't focus on it. But certainly it has a major impact because, and in the UK as well, in London, the pollution level went down and cleaner air when there was lockdown. And of course, when the activity started, it goes out because the more number of cars on the road, the more industrial activity and so forth. So there's certainly a relationship. But the problem is we can't lock down ourselves and wait. So we have to liberate ourselves and go. So that's the issue.
Definitely, I definitely agree. But maybe it's just an indication of some positive lessons that we can keep, of things that we could reduce as activities.
In addition, the reduction in airlines, the flights and so on, that causes severe pollution. So that also has been reduced because of the lockdowns and quarantine and so forth. So it's a temporary relief, not a permanent relief.
Definitely not. I hope not a permanent, because that would mean that we'd be in great trouble with other situations. Wonderful. Thank you for that. I don't know if there, I think that's quite comprehensive, but I don't know if there are other insights.
I've lifted up, Elena, 6.3% CO2 reduction.
Really?
6.3%, yes.
Well, at least we know that that's statistically significant, at least from the epidemiological point of view. Wonderful. That's very interesting. And at least we can keep that as a silver lining of something that can be learned. I'm also wondering. Oh, sorry. Go ahead.
Sorry, I was going to add. I mean, yes, in all major specialty cities, we have seen that local pollution went down during the lockdowns. I mean, we have seen also in different patterns of pollution, and in Venice, we saw like dolphins coming in the rivers and so on. Unfortunately, that would not be enough for climate change, though, just because even when the lockdowns, we had to have electricity running, food produced. So we had still emissions of greenhouse gases. And we need more drastic, let's say, cuts in different activities that they need energy consumption. What is an estimate is that in order to keep that goal of not exceeding the temperature increase, we need for the next decade to cut down the CO2 emissions by 10%. Sorry, actually the fuel consumption by 10%, which is a lot. And even if, you know, we reduce now, we're not gonna see most of the aspects of climate change will still persist for years. I mean, nothing as to cut us, you know, back by trying, but it should be, especially the lockdown made, I think, all of us see how much we interact with the environment and also with life and animals.
That's very true. That's very true. I think it's been a lesson on many levels. And since we can't directly, from what it appears, fix the outcome, going to the other end of the spectrum, which goes back to the first presentation on overpopulation, as an epidemiologist, I was wondering of the following issue. It's very interesting, the data that was presented regarding the number of children that families should have and the strategies that should be employed. But just knowing, even in the Mediterranean region alone, that there are countries that are actively promoting, one of them being also Cyprus, Greece, Israel, and other countries across the world that actually promote having larger families, and there are actually benefits through government strategies. At the public health level, how do you feel that this comes to resolve matters when we have to all obviously get together at the same table and agree on a common global strategy, when we have conflicting strategies at regional or national levels? How do you feel we should develop this? Is this something that should be surpassed and go directly to the global health level, such as the WHO, or should we leave it up to the countries to have that autonomy to decide how they want to proceed with their population development strategies?
So I'm going to be saying a statement which is not politically correct, because as you know, in Europe, the replacement level is about 2.6 per couple. So that is going down. And in many countries like Germany and other countries like Japan, it's less than 2. So it doesn't even come to the replacement level. So the governments are promoting more and more people to have more children and so on, so that they can come to the replacement level. Thus, at a country level, there is a problem, as you mentioned, Elena. You know, they are trying their hard, and that's the politically correct thing to do for them to promote their population to replace their levels. And the other side of the coin is actually because in these countries, the older population numbers are increasing. So there is not enough younger population to earn and put the money aside and look after and so on and so forth. So they can get some immigration labor force, but still they can't manage. So there are complex problems in terms of population balance. But coming to countries which are doing economically not so well, like in sub-Saharan Africa, the numbers can be 6, 8, 10. Sometimes there are 2, 3 marriages. There are a number of children. If you see some films, you can see 16, 18 children. So how can we tell them not to do? There is no contraception available. So there should be some incentives to reduce the family size. They have bigger size because number of children die on the way. So they want to have as a insurance or sure policy to have more children. Secondly, they want more hands to work in the farm, etc. So this is so there are one thing the people can, as a global village, can look at is actually how do we really subsidize them to limit the family and give them funding and so on to limit, but at the same time have a better existence. And a better existence means food on the plate, roof over their heads, better education and health. So these are the 4 areas which they have to focus on. And they had to build up some sort of strategy to do that. But they had to be plain about it rather than what I call as pussyfooting, saying, oh, you shouldn't have children or something. You know, you have to say, yeah, if you want to really have a better life and achieve SDG goals 1 to 17 in your own countries, then you can't sustain it without controlling a few factors. And controlling the few factors are these. And one of it is the population explosion. And that is something that we control and we will subsidize by funding. So you have better nutrition, better housing, better education, better health. So how can we achieve that is the main thing. So if I'm a global politician, I will take it that way. But country to country, you know, each country will strive their own, and politicians will sing the tune which will bring them votes.
That is the reality of matters. That is true.
But I think, Arul, you will be a good politician, of course, saying that, a good person rather saying that, but a bad politician if you're a strategist. Because you're probably think, I mean, you have raised some very reasonable sort of arguments to convince these people. So why don't they actually do this, implement this policy? For one very simple reason, you have to have countries that produce cheap labor, and these are countries that have lower educational level, you know, and then Africa will be the next move of a lot of the big strategic powers to produce goods, actually be able to overcome the Chinese domination. So I think they need them to live this lifestyle. Unfortunately, politicians and strategists are thinking this way.
Yeah.
Unfortunately. I know we have 1 last minute left, so I'm going to try and squeeze one last question in. Given that climate health is an emergent area, especially in epidemiology and public health, where do you see us going from here? What is the projected need? So for us to move forward, obviously population is one of the issues, but do we have any projections on where we will be in relation to diseases, in relation to animal health and needs? Where will we be 5 to 10 years from now?
That's a difficult question to answer, Elena, but I think Souzana's last slide summarized it all. That means that as individuals, we have some contribution to make. As an organization like the university can make some contribution, and as a country, they can make some contribution. So I might just propose with the University of Nicosia, we will go the first solar university in the world can be University of Nicosia because of sunlight, and you can get it. So you have to promote that type of concept to think big so that you can get some achievement. It's not going to change the world, but at least it's something you can be proud of. So individually, organization-wise, and country-wise, each one of us had to think.
Thank you. I think that's a very positive note to close on. If any of the panelists have any other positions to make before we close for today's session.
Just to say, Elena, I mean, you're asking where do we go from here? I think that if we're looking from the animal perspective now, which is the way I approached it, I think probably some of you probably have been alarmed by the fact of how much of gas emission animals are producing, and also if these animals are living in bad conditions, the situation gets worse. So I think we just need to become a little bit more aware of the environment we are actually putting these highly valuable animals for us, which are producing stable for us. Because if we change that, we will make a very significant contribution towards improving climate change. It's amazing how much cattle in particular are actually contributing to the greenhouse effect. So better living conditions and perhaps eating less meat.
Yes.
So I think we have a lot to address and a lot of
But
work.
you can eat a lot of halloumi, that's okay. Halloumi is okay. You can buy.
Wonderful. So I think we have a lot to address and a lot of work ahead of us at the public health levels, as well as the clinical levels and the veterinary levels in relation to tackling this emerging and established condition for our planet. Thank you very much for giving us the honor and the pleasure of having this opportunity to see your presentations and listen to your position statements. Thank you very much to all the members of the panel, as well as to our audience for their attendance and their contributions to a lively discussion. Unfortunately, our time is up, so I would like to wish everyone a wonderful evening. Thank you very much once again.
Thank you. Thank you very much. And all the best.